Hello. So today I want to talk about a continuation of kind of the last video where we kind of discussed how to solve some algebraic equations and what algebra is in general in terms of finding your constant variables, solving for them for specific reasons and or situations. But now I want to talk more about behavior. So in behavior, we have to talk about graphs. With graphs, I think the best way to just start off is to just think about a linear equation. So we will have a line that goes through the origin, which the origin in this case, or in most cases, is just 0, 0, since that is the center of the r squared or the two-dimensional, plane. We won't really get too much into that, but the idea, since we're in the second dimension, we have our two coordinates, x and y, x being horizontal, y being vertical. From here, you would see, we will then see the origin should be at 0, 0. My line's a little off, but it's okay. From here, we look at this linear graph, and we can say we'll use this as an example of y equals x. So all lines have the linear equation form of y equals mx plus b. M, in this case, is being your slope. Y and x are just your coordinates for that specific point that you're looking at. And b is your y-intercept. Okay, so your y-intercept just means that when x is 0, aka when it lives only on the y line, then you have your y coordinate, or your y-intercept is where your line crosses that y-axis. So from there, because a line, just to also point that home, is infinite on both sides. So whether increasing or decreasing, a line is something that will go on forever. So at some point, it will cross the y plane. Now, depends on how long that takes, is depending on the slope, where it starts, things like that. But at some point, it will, because every graph or every line will have a y-intercept. So because of that, we then continue on to say, let's say, for example, we have a graph, and let's say at 3, we have a point in the graph. That point of the graph would then be our y-intercept. So, for example, the y-intercept for the first example was just 0, so that's why there's nothing there, because at 0, the origin is where it crosses the y-axis. So then here, the line will cross the y-axis at y equals 3, x equals 0. So our equation would look something like, let's say our slope is like 2, and then our y-intercept is 3. So then you would look and see, because it's a plus 3 because it's on the positive y-axis, with this being the negative. So to think about it, your x and y are both positive. One is going up or to the right for x and y respectively. Then you have plus y here because your x is still going up, but you have a negative, but then you have negative x. For here, you have a negative x and a negative y. And then for this quadrant, you have a positive x and a negative y. Now, in the algebra, you don't talk much about the quadrants, but this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. But if you go into trigonometry, you will hear about that a lot because that's where the unit circle comes in. But that is a discussion for another video. So from here, if we take all this away, we can now do an example where, yes, when you're looking at the graph, it may be easier to tell certain ideas about what your function will look like because you can use some of the points and examples from the graph to determine that. But when you're giving a graph and then say told to find the slope, it can be a little bit more difficult. So let's say we have 2, 4, 6, and now 8 right here. So you have your y-intercept at 8. Then let's say you have another point. Let's say 1, 2, 3, 4. So let's say at 2, 4. You have another point. You know that these 2 points connect the graph like this. Something like that, right? So, don't mind my handwriting, but the idea would then be that we know we have the 2 points, 0, 8, our y-intercept, and we have the point 2, 4. Okay, so from here, we need to be able to try to find what is the rate of change, aka the slope, because that's all slope means, is to understand how, at what rate does your graph either increase or decrease. So technically, since we read left to right, this graph we know is decreasing, so we know our slope needs to be negative. But now, the way that we will find it is by using the slope finding formula, which in its standard form is written x2 or y2 minus y1 over x2 minus x1. This can technically be written as y1 minus y2 and x1 minus x2, but it just depends on which order you do it in. You just have to be mindful of that. But most people do it y2 minus y1, x2 minus x1. And the idea also is rise over run. So that is why the y will always be the numerator and the x will be the denominator. So now we just use this. I will use it in its standard form, and now we will use, you have to assign the variables. You can do it freely. It doesn't matter which one you choose, which like coordinate you use to as your y1 or your y2. So I will just do the top one as x1, y1, and the bottom one as x2, y2. So now you just plug in. So we have 4 minus 8 divided by 2 minus 0. So now you have 4 minus 8, which is negative 4, over 2, which is 2, positive 2. Negative divided by a positive, still negative. So negative 4 divided by 2 is negative 2. So we now know our slope between these 2 points is negative 2. So, and because it's a line, we know that relationship will remain constant. Therefore, the equation is y equals negative 2x plus 8. And now you can use this to find any other point that would belong on this line that connects those 2 points. Technically, be mindful that depending on your question, it may be worded differently, but this would be the idea for answering that question. So from there, those were linear graphs. Well, that's just singular linear graph. Actually, we'll talk about now parallel and perpendicular lines. So the idea with parallel lines is that you have 2 lines, again, infinite, that are going to never meet. That's the idea of parallel lines. They will consistently go on in both directions infinitely and never touch. They will never cross paths. The only way for that to be possible is if they have the exact same rate of change or the same slope, because at that form, them being at 2 different distances and also increasing and decreasing at the same time will never allow them to cross. So because of that, you know that when you have 2 parallel lines, so let this be, we'll call this A, call this B, line A and line B. And then we'll even do that just to signify. So we have line A, line B. We know that these are 2 parallel lines. They tell you that line A is parallel to line B. Because of that, when we know that those 2 relationships exist between these 2 lines, then we know that we need to have a slope. The only thing that's going to be different about these is for line A and for line B, the only thing that will change is the intercepts. Because if they had the same intercept, then it would just be the exact same line. So we know that these are the only things that changes. So once we find the slope for one, we know that we can find the slope for both. So let's say they told you the x-intercept here, which is, let's say 2, 2, 0. And let's say they told you here I don't know, let's say 7, 13. So just using the same formula, we can say, now let this be the y2, x2, let's just be x1, y1. Now you can say 13 minus 0 over 7 minus 2 gives you 13 over 5. So that is your slope. So then you know that's the slope for both lines because they're parallel. So now you know, we'll just keep with YA for now. Or actually, we'll do YB. So we know YB is equal to 13 over 5 x plus dot dot dot. Because we do not know, well, C in this case, we do not know that yet. So because of that, what we can do though is plug in. Since we know 2 points, we know points on the graph, and we know that we can just plug in x and y and we have the slope already, then we can just use one of these coordinates to then plug in. I would personally suggest using 2, 0 because it makes your equations a lot cleaner. So you would plug in 0 for y equals 13 over 5 x, which is 2. So in this case, so then 2 plus b. Now you solve for b. So you got to do 13 times 2, which is 26. So now you have 0 equals 26 over 5 plus b. Now you need to get b by itself. So you subtract 26 over 5 on both sides. And because of that, that leads you to say that b must be equal to negative 26 over 5, which is about negative 5.1 or something. So because of that, that is now your intercept. So now you know the intercept for this one, for YB, but now you need to know, so 13 over 5, yeah, 13 over 5x minus 26 over 5. So those are the, for that graph, or for that line. But then for A, you need to be able to find another point on its graph that would give you, say, follow the same rules. If they given some points on the graph, that you can then use that to try and find the x-coordinate or the y-intercept. But understand that in this case, they may just give you 1 point. So let's say that's 1, or let's be consistent. So let's say this was 3, 20. So because of that, when we look at when you look at this graph, you already know the slope because you found it on the line B. You know the same lines, same parallel lines have the same slope. Therefore, use the same equation to try and find the B intercept. So in this case, you would just plug in for line A again. So you would just say, since you're only given 1 point, plug in 20 for your y, 13 over 5 times 3 plus b. Solve b again. And really make sure that if you're doing this, you should really mark that these are 2 different b's because they're not the same b. So because of that, 13 times 3, 39 over 5 plus b1 is equal to 20. So then subtract again on both sides by 39 over 5. And let's make a little bit of room. So I will get rid of this. So we have 20 minus 39 over 5 equals b, 1. So now we got times by 5 on both, by 20 to get the same denominator. So then we can subtract. So 100 over 5 minus 39 over 5 is equal to 61 over 5 is equal to b1. So this would equal, this intercept be equal to 0, 61 over 5. And then that'd be it. So that's the idea of parallel lines. Usually a lot simpler once you understand the relationship between the two lines. But now we go on to show perpendicular lines. And so perpendicular lines follows a trend of where you would say a line exists. And now we're basically rotating this line 90 degrees. So then you would have a perfect right angle connecting these two lines at every corner technically. But the idea would be that because of this, since you rotated at 90 degrees, what would the slope be? Because they are definitely intersecting, unlike parallel lines. They're intersecting at a 90-degree angle. So because of this, the relationship between, when dealing with rotations, you learn that the slope with perpendicular lines are the opposite reciprocal, or negative reciprocal. So say if, again, let's say this is line A, line B, and you were given that line A's slope is, so we'll say line A slope is, say, 7. Something simple. Then line B slope, if perpendicular to A, must be -1/7, because it is the opposite, or the reciprocal, which, think of every whole number or integer, can always, just solely the integer can always have an over 1, can be over 1, because anything divided by 1 is itself. Therefore, you can always do that. So because of that, you write in that fraction, you can then flip the numerator and denominator, so 1/7, and then you need to then times it by -1. So if it was -7, then the reciprocal negative would be 1/7, because just because this is negative doesn't mean this stays negative either, because you just times it by -1, which is going to give you positive, and then you flip. So when given that, you could see if, say, you were given 2 points on this, and say this point, let's say this point. So you have, let's say 5, 12. Let's say this is -3/7. Okay, so now again we do y2, x2, y1, x1, and now the problem is that you need to solve. So solve for slope. So they gave you the 2 points on line A, so they want you to use it to find line A slope first, and then you need to then use that to relate it to find the slope of B. So we need to first find the slope. 12 minus -7 divided by 5 minus -3. So because of this, you think double negative, keep change. So plus plus. So 12 plus 7 is 19, and then 5 plus 3 is 8. So then you're left with 19/8 is now the slope for line A. And then you can even use this to try and find the actual equation for line A. So let's just say for line A we have 19/8 XA plus BA. So now what we need to do is relate this by putting in one of these numbers for said function. Now I did pick some ugly numbers, but we'll go -7 equals 19/8 times -3 plus BA. Now solve for A. So we need to do negative 3 times 19, which would give us about, yeah, 57. Okay, so negative 57 over 8 plus BA, which is negative 7. So then now we have to add negative 50, or sorry, add positive 57 over 8 is equal to, and then plus 57 over 8. So now relate this back over here. Sorry, kind of scribbling. So to relate it back, we would say negative 7 plus 57 over 8 is equal to BA. So now you need to find like, so times it by 8 on both sides, so you get negative 56 over 8 plus 57 over 8, so you're left with 1 over 8 is equal to B. So now you know that the intercept here is 1 over 8, 0. So now it tells you, okay, since you know that the slope originally was 19 over 8, then you know that for line B, the slope is negative 8 over 19. Because you just flip the numerator denominator, made it negative, because it was positive. So you times it by negative 1. And there you go. So that is lines and graphs and perpendicular lines and parallel lines. This then now extends to parabolas. So let's say for all those equations, we had the standard form of mx plus b with the order of the x being 1, aka the degree. Technically, that was the highest degree in that equation. Therefore, they came out as the lines when it's just a 1 power of 1 graph, or leading order is 1. When the leading order of the graph is 2, so usually you will see it written out as y equals ax squared plus bx plus c quadratic, you could then have, say for the most simple type of graph, parabola. So let's say that bottom is at the origin, and this is follows the graph y equals x squared. Positive. But the idea would be that when you have a positive leading term meaning what is the highest degree in your graph and what is a symbol attached to it, and that is why you will learn to write your equations of your polynomials in descending order so that you can easily identify the behavior of what the graph should be. So because we know that this was positive, we know it must have a minimum, aka whatever that point is at the bottom, and we'll get to that. We'll use the axis of symmetry to be able to find that out. So when you use, say, y equals negative x squared, you know that this flips the graph to get this across the origin. So while you have y equals negative x squared, you now have a maximum, and it will continue to go down, because this is saying that every number, which would be positive, being squared, is then times by negative 1. So it will always be negative. And you have to be very mindful when you look at the leading term, because you have to be careful that, say, maybe it's not written like this, because this is still equal to this, but this is equal to that. So you really have to be mindful of where that negative is and how it relates to your degree. Because now, let's say this is positive, but if we extend this to 3, then negative 1 times negative 1 is equal to 1, but times negative 1 again makes it back negative. So this would make this negative. But that would be a whole different equation because this is cubic. But either way, that is another conversation. I just wanted to kind of point out that because that trips up people a lot. So with parabolas, I talked about the axis of symmetry. So let's say you did have y equals x squared, and on y equals x squared, let's say you just picked a number. Let's say x equals 3. Then you know that 3 squared is equal to 9. So we know that this is a point that exists on this graph. So we know that we have one point of 3, 9. Now we want to find the axis of symmetry. So the axis of symmetry is based on this formula up here, which axis of symmetry is equal to negative b over 2a, which relates somewhat to calculus, but we won't necessarily get into that. But this is doing calculus because you are finding a rate of change and you're technically basing this off of the derivative of something. So, but if you take on later classes, you will see that. So negative b over 2a just follows this formula. So then you just look here to see where it relates. So the axis of symmetry here, since you don't have a bx term, you don't have a term connected to just a degree of 1x, and then you know that negative b is equal to 0. So then you have, so b equals 0. And then you have the a being equal to whatever in front of that leading term of x squared, which in this case a is equal to 1 because there always exists a 1 in front of all of these variables because 1 times anything is the self. So you can put a 1, so you have a equals 1. Therefore, to plug in back into the equation, you get negative 0, which doesn't make sense, but negative 0 over 2 times a, which is 2, because 2a gives you that, but that makes that the axis of symmetry is just equal to 0, because 0 over anything is 0. So therefore, we know that the axis of symmetry in the x coordinate, mind you, the axis of symmetry tells you the x coordinate. I should have mentioned that. So it gives you the x coordinate of your min in this case. So we know that the min's x is 0. So now what we need to do is plug back in to the original equation to find out our y. So we would plug in y is equal to 0 squared, which is just 0. Therefore, the minimum is 0, 0. And now we can extend this to another graph. Let's say y equals 2x squared plus 5x plus 2. And it said, okay, will this have a minimum or a maximum? Well, since this is positive in the front and it's squared, we know it must have a minimum. So we know we're finding a minimum. So now we just use our axis of symmetry to find that b is equal to what? 5. And our a is equal to 2. Now we plug back in to get negative 5 over 2 times 2, which is 4, to equal our x coordinate. So we know that our minimum would be, for our x coordinate, it's negative 5 over 4. And now we need to put in negative 5 over 4 for each of these terms that has an x. So let's make a little room. So we'll have 2 times negative 5 over 4 squared plus 5 times negative 5 over 4 plus 2. And I'll move this more out the way as well. So because of that, we can then say, okay, negative 5. When you do squared for fractions, you just square the inside. So this is the same thing as saying negative 5 squared times 4 squared plus negative 5 times 5. Think of this as over 1, so you just multiply across to get negative 5 times 5, which gives you negative 25 over 4 plus 2. So now 2 times negative 5 squared, which gives you 25 over 16. Again, plus, or we can change this to a minus 25 over 4 plus 2. And we'll end up combining like terms, but for now, this is okay. So then you have 2 times 25, which gives you 50 over 16 minus 25 over 4 plus 2. So now we need to find what this equals. So we must find like denominators, which in this case will be 16. So I will get rid of this to get 50 over 16 minus 16 over, so since you multiply this by 4, multiply this, the numerator, by 4 to get 100 plus 16 at the bottom. So you multiplied the 1 by 16, so 2 times 16, which is 32, to get 50 minus 100, which is negative 50, plus 32 over 16, which that is equal to negative 18 over 16, which then you can simplify by dividing by 2 to get negative 9 over 8. And that is your y. So then you know that your x, your axis of symmetry, or not your axis of symmetry, sorry, your minimum coordinate for this equation is equal to negative 5 over 4, comma, negative 9 over 8. And you can use that for any quadratic equation. This only works for quadratics. We can get into the different behaviors and concavity of cubic equations and extending that out to however order polynomials. But the idea of solving quadratics in this case will be very prevalent in what you do in college algebra. It definitely comes up, definitely tripped up people. I think in the next video, I want to discuss more about factoring and division of quadratics. But for now, I will leave this here. Let me know if I should add anything or if you have any questions. Thank you for watching.